On completing this course, the students will be able to understand how to connect the nodes from the last node of the list to the first node, and will be able to create the various types of circular linked list.
The circular linked list is a list in which the pointer of the last node is connected to the first node of the linked list. Here the figure shows that the last end of the node is connected with the header node, that is first node of the linked list. Types of circular linked list. Circular linked list can be classified as circularly singly linked list and circular doubly linked. Singly linked circular list. A singly linked list is a linked list in which the last node of the list points to the first node. In the singly linked list, a node will travel only in the forward direction and the last node will point to the first node. Declaration of a node. Type def struct node pointer position. Struct node int data position next. Routine to insert an element in the beginning. Inserting an element in the beginning of the linked list. Void insert beginning int x in list L. Position of the new node, it is to be declared. New node is equal to struct node star malloc size of struct node. If new node not equal to null, then new node data equal to x, new node next is equal to L next. L next is equal to new node. In this figure, it is showing a singly linked list implementation. Now, we are inserting element 5 in the list at the beginning of the linked list. Now, the list is cut from the header node to first node and the link is performed and is connected at the beginning of the node where the insertion of 5 is proceeded. Routine to insert an element in the middle. Inserting an element in the middle of the linked list. Void insert mid insert int x list L position p. Position new node. Then we are giving the structure to the new node. New node is equal to struct node star malloc size of struct node. If new node not equal to null, new node data x. New node next is equal to p of next. P is nothing but position. P next is equal to new node. Now we are inserting the 25th element in the list in between two nodes. Routine to insert an element in the last. Now we are inserting 40 data 40 into the last node. Routine to delete an element from the beginning. Now we are deleting an element from the beginning of the list. Void delete first list. Position temp. Temp L next. L next is equal to temp next free temp. Now we are assigning the 10 as temp where the 10th node will be deleted or the data in the node to be deleted. Routine to delete an element from the middle. To delete an element from the middle of the list. Void delete mid int x comma list L. Position p temp. P is equal to find previous x comma L. If is lost p comma L, temp is equal to p next is equal to temp next free temp. Now we are deleting the 30th element from the middle of the list. Then the connection is proceed between 20 and 40. Considering the 30 as a temp element to be deleted. Routine to delete an element at the last position. Void delete last list L. Position P comma temp. P is equal to L. While P next equal to L. P is equal to P next. Temp P next is equal to L. Free temp. Now we are deleting the last position of the list. 30 is deleting and the link is connected from 20 to the first node of the head. Doubly linked circular linked list. A doubly linked circular list is a doubly linked list in which the next link of the last node points to the first node and previous link of the first node points to the last node of the list. Declaration of the node. Type def struct node position. Struct node int data position next position previous. Here the data flow occurs in both directions, that is forward direction and as well as in backward direction. The link will be flowing through the last node to the first node and first node to the last node by pointing the next and the previous. Routine to insert an element in the beginning. We are inserting a new node at the beginning. Void insert beginning int x list L. Position new node. New node is equal to struct node m alloc size of struct node. If new node is not equal to null, new node data is equal to x, new node next is equal to L next. L next previous equal to new node. L next is equal to new node. New node previous equal to L. Routine to insert an element in the middle. Void insert mid int x list L position P. Position new node. Where we are inserting the new node, we have to position in the previous node. Now we are creating a new node with its structure. New node is equal to struct node pointer m alloc size of struct node. If new node is not equal to null, the new node data x, new node next p next previous equal to new node, p next new node previous is equal to. Routine to insert an element in the last. Void insert last int x list L. Position new node P. New node is equal to struct node pointer m alloc size of struct node. If new node is equal to null, P is equal to L. While P next is equal to L, P is equal to P next. New node data is equal to X, P next, new node. New node next is equal to L, new node previous is equal to P, L previous is equal to new node. Now we are inserting the 30th element in the last node. Routine to delete an element from the beginning. Void delete first, list L, position temp if L next is equal to null, temp L next is equal to temp next previous is equal to L free temp. Rotate to delete an element from the middle. Now we are deleting an element from the middle of the list. Void delete mid index listel position p temp. P is equal to 5 previous x if is lost p comma l. Temp p next, temp next. Temp next previous is equal to p. Free temp. Now the connection is performed between 10 and 30 and the new link will be formed. Rotate to delete an element at the last position. Void delete last list L. Position P, comma temp. P is equal to L. While P next is not equal to L, P is equal to P next. Temp is equal to P, P next, previous is equal to L. L previous is equal to P previous, free temp. Advantages of circular linked list. It allows to travel the list starting at any point. It allows quick access to the first and last records. Circularly doubly linked list allows to traverse the list in either direction, both in forward and backward directions. Applications of list. The circular linked list is applied in polynomial ADT, radix sort and also in multi-list.
Now we will move on to question and answer section. The first question is, what differentiate a circular linked list from a normal linked list? The option A is, you cannot have the next pointer point to null in a circular linked list. Option B is, it is faster to traverse the circular linked list. Option C is, you may or may not have the next pointer point to null in a circular linked list. Option D is, head node is known in circular linked list. The answer is option C. You may or may not have the next pointer point to null in a circular linked list. The second question is, which of the following application makes use of a circular linked list? Option A, undo operation in a text editor. Option B is recursive function calls. Option C is allocating CPU to resources. Option D is implement hash tables. The answer is option C, allocating CPU to resources. Thank you, students.